Our lesson last time introduced box and whisker plots, and today we're going to compare box and whisker plots, and we're going to do a little review of what we learned last time. Starting at the top, the blank describes the number that is the middle of the data. Well, the middle of the data we have called the median. Okay, so the median describes the number that is the middle of the data. 50% of the data is below the median, and 50% of the data is above the median. Using quartiles, the median is quartile number 2, so we'll call that Q2. All right, after that, the blank describes the median of the lower half of data. Okay, when you're only looking for the middle of the lower half, we call that the lower quartile. The lower quartile describes the median of the lower half of data. 25% of the data is below the lower quartile, okay, and we call that Q1. And then the blank describes the median of the upper half of data. The median of the upper half of the data is called the upper quartile. The upper quartile describes the median of the upper half of data. 75% of the data is below the upper quartile, which we call Q3. In example 1, we're told that the double box and whisker plot shows the shopping time for two different groups. Which choice best describes the comparison of the double box and whisker plot? Okay, so we can see that this is measuring the shopping time in minutes, and we've got two groups, Group A and Group B. And what we want to do is figure out which one of these is the best description of the comparison of the double box and whisker plots. So A says that the position and lengths of the boxes and whiskers are similar. Okay, so let's start with the positions. Look at the boxes. Are they about in the same location, or are they very far apart from each other? Well, looking at where the boxes are, I would say that they're about in the same position. They're pretty much one on top of each other right here. All right, so I think that the positions are very similar. How about the lengths? All right, are the lengths similar? Well, this box and this box down here, they seem to be about the same length to me, just eyeballing it, so that looks good. Same thing with the whiskers. If I look at the whiskers appear to be in kind of the same place, and their lengths are very similar as well. So A is looking like a good choice, but we'll read through the others. B says that the boxes are similar, but the whiskers vary significantly. Well, I think that the boxes are very similar to each other, but the whiskers, I don't think they're very different at all. So I wouldn't agree with this statement that they vary significantly. So I'm going to cross out B. All right. Letter C says that the boxes vary significantly, but the whiskers are similar. Well, again, I think that the position and lengths of the whiskers are very similar, but the boxes vary significantly. I don't think I agree with that statement. Again, I think they're about in the same location and they're about the same length, so I'm going to cross out that one. The position and lengths of boxes and whiskers vary significantly. Well, talking about what I said before, I don't think that one's right. I'm going to go ahead and say that A is the right answer. The position and the lengths of the boxes and whiskers are very similar to each other. Okay, now using this double box and whisker plot, we have a few more questions that we're going to answer. The first question says, which group has the shopper who shops the longest? And so when we're looking for the shopper that shops the longest, we're going to look for the maximum, okay? So I'm looking at the maximum of each group. Group A, there's their maximum, and it's just about 65 minutes, maybe a little bit under that. All right, Group B, though, it looks like their maximum is a little bit beyond that. So the shopper that shops the longest would be found in Group B. Group B has the shopper that shops the longest. The next question says to state the median for each group. So I'm looking at the median. All right, the median is in the box between Q1 and Q3. So this line right here for Group A, this line right here for Group B. Let's start with Group A. All right, we drop this line down and it's a little bit beyond 45 minutes. So I would say something about maybe 47 minutes could be the minimum, or excuse me, the median for Group A. And for Group B, I drop that line. That line goes down to 40 minutes. 40 minutes is going to be the median for Group B. And so then the follow-up question there says that Group A's median shopping time is blank minutes more than Group B's median shopping time. Well, comparing these two numbers right here, it looks like Group A's median would be 7 minutes more than Group B's median shopping time. Example 2 asks us to compare the spreads of the two box plots from example 1 by calculating the interquartile range for each group. So we're going to go ahead and do that right now. I'll give you a few moments to do that. Remember that the interquartile range is calculated by doing Q3 minus Q1. In question 3, they ask which group has a greater variability in the bottom 50% of shopping times. The bottom 50% goes from the minimum to the median. And so I'm going to bring up the graphs again. Here are the graphs that we were working with. Okay, and we're only going from the minimum to the median. And so looking at Group A, there's their minimum and there's their median. Okay, Group B, there's their minimum and their median. And it looks like there's more of a spread if you look at Group A. They seem to be further apart in Group A than they are in Group B. So we can go ahead and say that Group A has a greater spread in the bottom 50% of shopping times. Number 4 wants to know which group has a greater variability in the top 50%. Okay, so I'll bring the graphs back again. This time we're looking at from the median to the maximum. So we're looking at the median to the maximum. There we are for Group A. Okay, for Group B, there's their median and their maximum. And it looks like that Group B has a bigger spread than Group A when you look at the top 50% from the median to the maximum. So we can go ahead and say that Group B has a greater variability in the top 50% of shopping times. In example 2, it says that the box plots show the distribution of the number of team wristbands sold daily by two different stores over the same period. So we can see store A and store B, and this is the number of wristbands that they sold daily. Store A's median is about blank. So let's go to store A, find their median, drop that straight down, and it's a little bit more than 40, so I would say maybe about 42 would be a good number. Store B's median is about blank. Store B, well, there's their median line. We drop that straight down, and it's very close to 50, so let's go a little bit more than that with 51. Store A's median is close to Store B's blank. Okay, well, here's Store A's median, and if we bring that straight down, it's very close to this value in Store B, which is their minimum. Okay, Store A's median is close to Store B's minimum. This means that about blank of Store A's daily sales were less than Store B's worst day. Well, remember that for Store A, the median here would mean that about 50% is going to be less than that. Okay, this means that about 50% of Store A's daily sales were less than Store B's worst day. Which store has the greater spread? Okay, well, looking at Store A and Store B, for spread, we're looking at their maximum and minimum. Okay, Store A, here's their minimum and their maximum. Here's Store B's minimum and maximum. Okay, and it looks like they're further apart if we're looking at Store A. Store A has a greater spread. Which store has the greater daily sales? Well, if we compare the 5 data points, the minimum, Q1, Q2, Q3, and the maximum, all right, well, it appears that Store B has the greater daily sales. Explain how you know. Well, Store B has a greater minimum. Okay, there are the minimums. Store B's is greater. Store B has a greater Q1 value. Okay, here's Q1 for Store B compared to Store A. All right. Store B also has a bigger median. We compare those. All right. Median. Okay. Q3 values. Well, again, it looks like Q3 is bigger in Store B. The only place where store A is greater than store B is at the maximum value. Okay, store A's maximum is bigger than store B's, but store B has a greater minimum, Q1, median, and Q3. So in general, store B has greater sales. Store B, in general, has greater sales. In this box plot, we're looking at the average minutes per night spent on homework. And question 3 asks, what percent of sophomores spend more than 60 minutes on homework per night? So let's find where 60 minutes would be located. Okay, 60 minutes, well, 0 is the minimum, Q1 is 20, Q2 is this 48 value right here, and Q3 right there is our 60 minute, which is our hour. Okay, so what percent spend more than 60 minutes? Well, if Q3 is 60, all right, well, 25% of the data is more than 60 minutes. So 25% is the number that is spending more than 60 minutes per night on homework. What is the range of times of the middle 50%? Okay, well, when they talk about the middle 50%, they're talking about the interquartile range. All right, the interquartile range, again, that's calculated by doing Q3 minus Q1. The Q3 value we can see right here is our 60 minutes. Our Q1 value is going to be 20 minutes. So if we do 60 minus 20, we're going to end up with 40 minutes. So the range of times of the middle 50% that they spend on homework is going to be 40 minutes. All right. Number 5 says, what percent of sophomores spend less than 20 minutes? Less than 20 minutes. Well, 20 minutes right here is your Q1 value. Less than Q1, well, again, that's 25% of your data. 25% of sophomores spend less than 20 minutes per night on homework. Would you expect the mean to be higher or lower than the median? Okay, well, in this example, it appears that a lot of the data is very close together except for the maximum way out here at 190 minutes. I would consider this number to be an outlier, and since it's much bigger, I'm going to say that that's going to make the mean become much bigger. So I'm going to say that the mean is bigger than the median. The mean is bigger than the median because the outlier of 190 minutes will increase the mean. If you have an outlier that's a lot higher than your data, well, then that's going to make your data, your mean of your data become much bigger. In question 7, they want the median price of a snowboard at Middletown Snowboards. So the median, again, is between Q1 and Q3, which are the right and left ends of your box. So Q2, the median is in between there, and we drop that line straight down, and we can see that it's going to be at $75. Question 8 asks, what is the value of the third quartile shown in the box and whisker plot below? The third quartile is the right edge of your box, which we see right here. So we drop it down. It's this line right here. That's 9, something, something, 12. Well, it looks like they're counting by 1, so that's 9. 10 is going to be the value of Q3. The box plot in number 9 shows the number of tickets sold for a movie during the month of June. Which conclusion can be made from the box plot? A says the second quartile, or the median, is 600. Well, we drop that down, okay, and that's at 4, which would be 400. These are in hundreds, so A is out. B says that the mean is 400. Well, the mean can't be figured out from a box plot, so that one's going to be wrong as well. C says that the range is from 300 to 600. Well, the range is the high minus the low. That's 100 and 900, not 300 to 600. So it's got to be D. 25% of the attendance is between 300 and 400. 300 to 400, that's Q1 to the median, which is 25% of your data.